Hi, welcome to the today's session. I am P.NAVEEN Kumar from S.A.E. Engineering College, Department of Artificial Intelligence and Data Science. Today we are going to see the topic about inference by variable elimination in Bayesian networks. In previous classes we have seen about the Bayesian networks and how to construct the Bayesian tree and decision trees in this one. By using the variable elimination algorithm, we are going to calculate the probabilities. In the previous classes, the enumeration algorithm can be improved by sustainability by eliminating the repeated calculations. The idea is simple: to do the calculation one, solve for the later use. This form of dynamic programming variable elimination algorithm is used by evaluating the expressions. For example, the intermediate results will be stored and summation of each variables are done while calculating the probability. For only those portions of the expression is that depends on the variable. We have annotated each part of the expressions with the same name of associated variable. These parts are said to be as factors. It will be denoted as f of x comma y, like that. A factor is a function from a tuple of random variable to the real number, or we can write the variable as x1 up to x as f of x1 up to xn. Let's illustrate the process of variable elimination algorithm by using a burglary networks. We already know the problem. To find out the burglary happens when John calls and Mary calls. We need to find out the probability by using a variable elimination algorithm. For example, in this diagrammatic representation, the alarm will ring when burglary or earthquake happens. If the alarm rings, John or the Mary will be calls. These are all the probability tables given by us. We have to, by using the probability values, we need to calculate the probability of an burglary happens when John and Mary calls. For example, probability of burglary happens John and Mary calls will be written as alpha summation of E and summation of A P of B into P of E into P of A by B comma E into P of J by A into P of Mary and M by A. From these repeated variables are separated. For example, P of B and P of E are constants. P of B is common for both the summations, both the variables. So it will be taken out from the both the variables. Summation of E into P of E summation of, and remaining things are in the formula. Then this will be separated as factor 1, factor 2, factor 3, factor 4 and factor 5 by using a variable elimination algorithm. Alpha into P of B is separated as factor 1 of B and then F2 of E, F3 of what are the variables inside the probability A, B and E, and factor 4 of alarm rings and then factor 4 of 5 of alarm rings. Here for the example factor F4 of A and F5 of A corresponding to P of J by A and M by A. Depending on A, because J and M are fixed by the query. They are therefore two elements vector in the burglary, in the variable elimination algorithm. For example, while creating a decision tree, we will get the tree like this. For all the values we already constructed the tree by using a Bayesian network. Here F4 of A, that means probability of John calls burglary happens, probability of John calls not burglary happens is the probability value taken from a tree 0.90 and then 0.0. 05 and Fi of A. Then Mary calls and when burglary happens, Mary calls when burglary not happen is the probability. Given two factor f of x comma y and g of y comma is with the probability distribution shown below, the pointwise product will be written as equal to h of x comma y comma is has three variables, so 2 power of k value will be 3 variables, so it will be written as 2 power 1 plus 1 plus 1, that means x, y and z. 2 power 3 have 8 possibilities. This will be calculated, these are all calculated as in this table. X and y is equal to one variable and y and z is another 2 variable. We have to calculate f of x comma y and then y of z. Then by using this one we have to calculate the h of x comma y comma z. For example, we will consider x, y, z, all the three things are true. That means xy is equal to true and z equal to true. That's the value 0.3 into 0.2. It will be written as 0.066 while multiplying these things. Then next possibility will be two conditions are true and z condition will be false. That means 0.3 and z will be false is 0.8. So 0.3 into 0.8 equal to 0.24. Then next condition is 1 is true, x is true and y is false and z is true. Here true false the value will be f of x comma y is 0.7 and then false true. Then z will be needs to be true. Z is true means you will get the value of 0.6 is equal to 0.42. If you multiply both the things by according to these things simultaneously we have to calculate the 8 possible values. And the next one will be elimination. We have to eliminate the summing out from the, we have to eliminate the variables by summing out. From the factor is done by adding the sub arrays formed by the fixing the variable to each its in turn. For example, sum out of h of x comma y comma z we will be written as h of small x of y z plus h of not small x of y comma z. These will be calculated by using h of x comma y z. These are all the variables. Subarrays formed by h of x comma y. If x is true, another possibility is true, false, true, 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 false. That means if x needs to be true, these 4 possibilities, and then x is false, these 4 conditions. These are all the 2 subarrays of h of x comma y comma z. By adding these things we will eliminating the one of the variable. Then next one by relevance. Let us consider one more query. P of John calls and burglaries is equal to true. That means P of J by B. This will be written as P of B into P of E. Then we have expanded these things means you will get this formula as like the previous one. Then will be the summation of Mary calls and burglary happens is equal to 1. So M is irrelevant for the query. In the other word, J by B remains unchanged if you remove M from the network. So because the M is the fixed variable, that's why they are saying it as it remains unchanged. Next week, that's it about the variable elimination algorithm. Next we can see some of gate problems. For example, consider a Bayesian network with the following conditional probabilities. P of A is equal to 0.6 and P of B by A is equal to 0.7 and P of B by not A is equal to 0.2 and then P of C by B is equal to 0.9 and then P of C by not B is equal to 0.5. We need to calculate the P of C using the variable elimination algorithm. First we have to write the probability by using the chain rule. P of C is equal to A summation into B summation of P of A into P of B by A into P of C by B. By using the variable elimination, first we expand the probability terms. For example, compute for A is equal to true and compute for A is equal to false. We have to compute the value when A is equal to true and when A is equal to false. When A is equal to true, we have P of A is equal to 0.6 and then P of B by A is equal to 0.7. And when A is equal to false, we will get the value of, for example, when A is equal to false, we will get the value as P of A is equal to 0.4. How you will get the value of 0.4? For example, P of A is equal to true means 0.6. That means we know that P of A plus P of not A is equal to 1. So P of A is equal to 0.6 and P of not A means, that means P of A is equal to false. The remaining value will get 1 minus 0.6 as 0.4. We already know the value of P of B by A is equal to B by not A is equal to 0.8. For computing the P of C, then you have a formula, summation of A, P of A into P of B by A into P of C by B plus P of not B by A into P of C by not B. Then we have compute for the each terms. We have substituted the value in this formula. You will get the result of 0.232. So then P of A is equal to true, we will get the value of 0.468 and P of A is equal to false, we will get the value of 0.232. So the final probability of P of C is equal to 0.7. This is the final value of a probability of C. So by using a variable elimination algorithm, we have calculated the probability of an C. That's all about variable elimination algorithm. We will continue the session in next video.